Hello all, this is Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about a case study on integration of clinical data with image processing for lung cancer diagnosis. Here I have taken some real-time examples for how image processing techniques will help to integrate the clinical data for lung cancer diagnosis. Okay, let's move on to the topic first. Okay, while taking lung cancer, a lung cancer diagnosis imports a poor prognosis with about 60% of patients dying within 1 year of diagnosis. Surgical resection of an early lung cancer has a favorable prognosis. After resection of a first stage bronchogenic carcinoma, a 5-year survival rate is 80% to 90%. C. After a resection of a first stage bronchogenic carcinoma, at the 5-year survival rate is just 80 to 90%. The goal of a chest computed tomography CT screening is the detection of pulmonary nodules in the patient risk of lung cancer. C. In the lung screening programs, I've taken the ILCAP, International Early Lung Cancer Action Program. Here, nearly 31,000 individuals, the mortality reduction is 8% and 14% in 5 of 10 years of screening. And in the batch 3210 individuals, no mortality reduction. And Mayo Clinic experience, here 1520 individuals, mortality reduction is 28% and 15% in 6 of 15 years of screening. And in NLST, about 50.00 current or former smokers results expected in 2010 to 11. See here. Here in this lung cancer detection, computed tomography plays a vital role here. CT in screening programs, see here the first step and the second screening stage and the third one and the fourth one. The final one is our outcome of CT. Here each low dose is helical multi-slice CT is around 300 2D. Images with the slice thickness is less than or equal to 1.25 mm. Each annotation by 1 or more radiologists up to 4, and nodules of diameter is greater than 3 to 5 mm according to the different protocols. Sometimes 60% between radiologists. See the first one, a person is fed into CT, and the second one, the screening with the help of CT, screening of lung, and the fourth one is slices, screening slices of lung cancer and the lung. See, in 3D image processing, we have two approaches. One is general approach, second one is lung CAD system, computer aided diagnosis. It is normally called as CAD. Here we have in general approach segmentation, feature extraction, classification. In segmentation we have definition of the lung volume and region of interest list. And the feature extraction we have characterization of the candidate nodules, and classification we have true or false positive classification. And the magic 5 CADs. Here we have the parallel approach. 3 different lung CADs are implemented in the same software framework. Some algorithms are procedures in common, and the data analysis is performed in cross-validation like blinder. The CAD systems were validated with 3 different databases. See here, this is a perfect picture for how image processing techniques used for lung cancer detection. Here we have taken real-time approaches, real-time examples, real-time data. See the first one. First one is about lung segmentation. Second one, candidate nodule identification, where the cancer cells are present, like that we have to do. And candidate nodule feature extraction. And the last one is candidate nodule classification, like true positive, true negative, like that. False positive, false negative, like that we have to classify the candidate nodule. See, the first one is region growing, and here we have considered virtual ants, and the last one is about 3D multi-scale output and voxel based. Last one is See here in this one, here we have taken 15 discriminating features like volume, sphericity and ellipticity, compactness, Shannon's entropy, like that we have. After considering this 15 discriminating features, we have to identify the level of cancer cells with the help of region growing, and the outputs might be in 3D multiscale or voxel based. The last one, it shows the feature extraction. See here, with the help of CT image we can easily extract the features of the cancer cells, lung cancer cells. Actually this will be done for the cancer cells which are present in our body, but based on the applications we can choose the algorithms. Okay, see here, in this Magic 5 lung segmentation, a simple threshold 3D region growing is applied to the CT in order to segment the air inside the lung. Region growing wavefront simulation algorithm is applied in order to segment and remove the trachea and external bronchi. Morphological 3D closing is applied in order to refine lung volume and include pleural nodules. See here the region growing with CAD. Candidate nodule identification is first applied. It is the region growing based iterative algorithm is applied here. Second one is about feature extraction. Geometrical and statistical characteristics are extracted. And third one is nodule classification. Here we use rule based filter with neural network or support vector machine algorithm. For this region growing, in the previous videos we have discussed about region based segmentation, and in this case study topic how it is applicable, how region growing is applicable in real time problems. So we have taken a case study on lung cancer and we have applied region growing algorithm for CAD. CAD means computer aided diagnosis. The first step is candidate nodule identification, second one is feature extraction, third one is nodule classification. See the first one, region growing based iterative algorithm. Actually it shows the region growing. Okay, second one is feature extraction. Here we have features, geometrical and statistical characteristics. Third one is nodule classification. Here we use rule based filter with neural network or SVM. Okay, here we have virtual ants CAD. In this lung segmentation, candidate nodule identification, a virtual ant colony detects the vascular tree and the candidate's nodules. Here the feature extraction, geometrical and statistical features also extracted, and same for nodule classification we use a rule based filter and neural network. The only one thing is here region growing based iterative algorithm is applied. Same thing for lung segmentation and candidate nodule identification. Here we use a virtual ant colony detects the vascular tree and the candidate nodules. Based on the applications we can prefer either the simple region based or a simple algorithms for classification. Here we use virtual ant and rule based filter with neural network or SVM. In the previous one we use SVM or neural network, rule based filter with neural network or SVM. Here we use rule based filter with neural network. See, virtual ant CAD, how it works. And again we have to consider the voxel based neural CAD. In this lung segmentation, candidate nodule identification, we use the 3D multiscale Gaussian filter with detection of inward pleura surface normal intersections, and feature extraction we have roll down 3D neighbors intensity with eigenvalues of Hessian and gradient matrix for each voxel of nodules. And for nodule classification they use only neural network for voxel based neural CAD. See here how it differs from others. Okay, next one is about Magic 5 lung can results. Okay, the purple line, it indicates Magic 5 CAD on LADC database. Here we have taken samples from different databases and we'll get the output results based on the database. And same we have for green, red. Okay, here in Magic 5 CAD system, 3 parallel approaches to lung nodule detection and classification are done. Here the data are validated using 3 different CT lung image databases. Here the competitive with respect to the state of art systems are defined here. Based on the applications, we can define the algorithms and classifiers. In the previous videos in the March lecture series, we have discussed about image restoration and segmentation. In this image segmentation part, while talking about segmentation, we have to include the classification part. In this case study, I thought this case study will clearly describes how an image segmentation is done with the help of algorithms. After the segmentation, we have to do classification for further purpose. So we have taken lung cancer as an example, and we have taken some real-time examples, real-time algorithms to make this image processing techniques, how it works on real time. In this real-time case study, we have taken is lung cancer. So I think this will clearly indicates how lung cancer will be detected with the help of image processing techniques as a real-time example. Thank you.